All right. Sorry about that. So there's a meeting every there's this office and intel brief every Saturday, and it's supposed to go from 1630 until around 1700. And today it went as fast as I've ever seen it go in my life. Right at about 1650, the general sitting there, he looks at the clock and goes, "This is the first time we're ever going to get done with this by in half an hour." And I go, "That's nice, I'll be early to class." And then as I'm walking, it finished right at 1700. As I'm walking out the door, guess who grabs my arm and says, "I got to talk to you." General Farrell. And when a general says, "I need to talk to you," I guess you have to be a little bit late for class. So anyway, I apologize. It was kind of important stuff, so there's work that. All right, tomorrow, tests tomorrow, test number 2. What we'll do is we can go over the test practice if you want, but let's do it at the end, because I know a bunch of people already were here on Thursday, and we did go over that pretty extensively on Thursday too, so we'll go over that at the end for anybody who wants to stick around and do that. The homework this week, was it a little longer than last time? Yeah, was it a computer problem or a problem with like trying to figure out how to do it? Figure out how to do it?
Computer problem.
What was wrong with this? What was the computer issue? Couldn't figure out.
Mine kept freezing.
Oh, well, that's not good. Kept freezing, that's not good.
That's mine's going to.
Yours was freezing too?
Well, we in the same room, so.
Maybe that's like you're in the same room. Yeah, okay, I'm sorry about that. That was the issue. Yeah, the homework get a little more involved, and it does take a little longer. I hope it helps though, being able to click on the button that says, how do you do this? It takes a little longer, but it
does help a lot.
Multiple tries.
That new example does well.
New example helps out. All right. Well, what we're going to do today will not be covered on tomorrow's test. Straight up. Okay, the test will look very similar to the practice, kind of like last time. But what we're going to talk about today is more on linear functions and graphing them. Okay, so I'll put a graph, some kind of virtual graph paper up here, and we'll go with this. We'll see how these work. But remember, when we have a function that looks like this, f of x equals negative 3x plus 6. First of all this is saying is this side is a function of x, and all that means is y equals negative 3x plus 6. Okay, so if you have any concerns over the fact that I'm writing f of x equals this, just put a y there and go with it. Okay? Sometimes you have to plug into those things, but that's it. We could also write this like this. We could say 3x plus y equals 6 if I add 3x to both sides. Okay? Those are equivalent. They mean the same thing. Okay? And these are these linear equations in 2 variables. Okay? A times x plus b times y equals c. That's in this form here. If you get it in this form, you can graph these really, really easily. Okay? If you look at a graph, and you have some line going through here, where it crosses the x-axis is called the x-intercept. Okay? Where it crosses the y-axis, remember this is x and this is y, where it crosses the y-axis, that's called the y-intercept. If we can find those 2 points, isn't a line defined by only 2 points? You only need 2 points, you can always connect it and make a line out of it. You have 2 points. You can find as many points as you want, but if you have 2 points, in particular, the 2 points that cross here and here, then you can figure out what the graph looks like, and you can draw it. Okay? What point is this? Let's say this was 2 up, 1, 2, 2 up here. What point is that? Which point is that? If I was to do parentheses notation, it's 0, 2. Does that make sense? The x-coordinate is 0, and the y-coordinate is 2. How about this point if that was 1, 2? What would that one be? That would be 2, 0, the 0 there. So the way you find those 2 points is you set either y equal to 0, and that would give you this point right here, Or you set x equal to 0, and that would give you this point. And then we can find those 2 points and we can graph this. And it'll work every time, except for the case where the x or y doesn't exist, but then those are special cases, and we'll show you how to do that too. But for this one, 3x plus y, let's set x equal to 0. 3 times 0 plus y equals 6. What's the coordinate of those 2 points now?
6.
Y equals 6 when that goes away. So it's going to be 0 and 6. And we got 1 point. Check. Okay, let's set y equal to 0. 3 times x plus 0 equals 6. Well, 0 is going to go away. 3x equals 6. Divide both sides by 3, and you get x equal to 2. Y equal to what? 0. Nope, because we set it equal to 0. Not up here it was, but when we go back and say, let's just make that one 0, then we know it's 0. The point in this case would be 2, 0. Don't we now have 2 points? And we could graph those if we want to. Let's see, we've got y equals, let's see, first one was 0, 6. 0 across 1, 2, 3, 4, 5, 6. That's right there. And then we've got 2, 0. 1, 2, 0. And if I take my ruler and go right between those 2 points, there's your line. See how easy that is if you have an equation in the form like this? So easy. Okay, if you want to do that. Okay, easy to do. And pretty basic when you're just trying to say, I can set all this stuff equal to 0. Okay? Let's do another example. And while you guys are working on the example, I'll put the virtual graph paper on the board. So here's what I want to do. Use the intercepts to graph 2x plus 4y equals 12. Okay? Try that. Tough to see that now. What's the first thing we do with this? Nope, don't even bother with these ones. You can just start going and saying, I want to find those 2 points, where x equals 0 and where y equals 0. So pick one. Give me which one you want to do? X equals 0. 2 times 0 plus 4 times y equals 12. That's going to go away. 4y equals 12, divide both sides by 4, and you get y equal to 3. So our point is 0, 3, because we started with x equals to 0. 0 across 1, 2, 3. That. Okay, let's do the other one. If we now set y equal to 0, we've got 2x equals 12. I'll just cross out the y term. Divide both sides by 2, and you get x equal to 6. So it's 6, 0 now. 1, 2, 3, 4, 5, 6, 0. And there you go. Okay? We're done. And if you wanted to find other points on there, you can say, well, let's see. 2, 2. Let's see if 2 2's on there. 2 times 2 is 4, plus 4 times 2 is 8. 4 plus 8 is 12. So it does work. And that point happens to be right on that line as well. Okay. Not too bad to do that kind of stuff. All right. Now let's do this. All right, another one. Okay. The next thing we need to talk about is this thing called slope. What is the slope of a line? What does that actually tell you? I mean, when I say a slope, those of you guys who remember this. What's the slope of a line mean? Is there a difference between, let's pretend this was a line.
Is that a rise or a run?
Rise or a run, that's the way we define it. But it really just tells us the angle of it, right? How, what do we call it? How, like, slanted it is. It's really all it is, okay? And yes, the answer is, it's called the rise over line. It's the steepness, or the slantiness, if you want. Steepness of a line, the steepness of a line is its slope. Okay? How steep the line is. Okay? If a line goes through 2 points, let's say this point we're going to call x1, y1. So I'll do it this way. And the point up here, actually, yeah, let's do it this way. x1, y1, the point up here is x2, y2. What you do, and by the way, if x1 is not equal to x2, and this is you'll see the reason for this in a second. x1 is not equal to x2, okay? We take the change in y and divide it by the change in x, okay? And as Dan said, this is actually the rise over the run. In other words, the rise is up and down, and the run is side to side, okay? We can also write this for these 2 points as the rise, which is the y part, y2 minus y1 divided by x2 minus x1. Does it matter which point we choose for x1s and y1s? x1, y1. It actually doesn't. You could also write this as y1 minus y2 over x1 minus x2. And those two happen to be exactly the same number. Right? And the reason is because let's say this one was negative and this one's positive. Well, over here, this one will be positive and this one will be negative. And they're the same number absolute value-wise, so you actually get the same exact answer. So it doesn't matter which point you pick. Yeah, I just picked this one because normally it's rise over run. Okay. So let's try one, and then we'll see how it works out. Okay. Rise over run. Find the slope through 2 points. -5, 1. -5, 1. And 2, -3. Let's find the slope. So find the slope. You guys remember what the letter for slope is? What's that? MX. You're close. It's just one letter though. You had it. It's called M. I think it's Latin or something. I don't exactly remember why it's called M, but it's called M. M is the slope. Okay? All right? The slope in this case is, we'll make this x1 and this y1, and this x2 and this y2. Okay? So in this case, it's going to be y2 minus y1 over x2 minus x1, which is -3 minus 1 divided by x2, which is 2, minus -5. Right? -3 minus 1 is -4. 2 minus -5? 7. There's your slope. If you had made this one x2 and y2, and this one x1 and y1, you also would have got -4/7 for the slope. Right? What this means is if you happen to have a point here, let's say, the top is the rise. Let's start out here again. The top is the rise. So it's actually rising -4, which means it's going down. So you go 1, 2, 3, 4, and then you go run of 7. 1, 2, 3, 4, 5, 6, 7. And there's a point. And you can go from that point and do the same thing if you want. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. There's a point. Hopefully those points will line up so that you can put a line through them. Okay. And I almost did. Almost did. There we go. Okay. This happens to be called a negative slope. It's a negative slope because it's going down and to the right. Pop quiz hot shot. What do you think that slope would be? Positive slope. So it's going up and to the right. Okay. And you'll know it's a negative or positive slope because this number will either be negative or positive. Okay. If the slope happened to be 4 sevenths instead of -4 sevenths, you'd go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Like that. And it'd be positive slope. Okay. We also have a slope that looks like this. There's your line right there. Okay, that slope, let's think about it. Okay, that slope is how much rise from here to here. How much up does it go or down? 0, right? And then however many over you want. Right? It could be, it goes an infinite amount over, but you can pick 1 or whatever, it doesn't matter. But what's the slope of this line? 0 over anything is 0. So this is a 0 slope line. 0 slope. Okay? And in fact, this line goes both directions. What's the other one that we haven't covered? We've got the slanty ones, this one, the horizontal one, the vertical one. Now, 2 things about the vertical one. Okay? If you had a line that, I'll just draw it kind of dashed like this. Okay? That line, okay, the run is any value you want. Sorry, the rise is any value you want. Let's say we'll pick 5, doesn't really matter. How far over does it go? 0. What's 5 divided by 0? Not 0, not 5. What is it? This we had this on the last test. Undefined. You can't divide by 0. So this has got an undefined slope. Now I'm going to drag something out of your brains from last week as well. It's an undefined slope. If I have a line that's vertical, does it pass the vertical line test? In other words, is there only one point in a vertical line on that? No, it doesn't. You can't. If you drew a vertical line, you'd hit every point. Okay? So it can't even be a function. So that's one of the other reasons it's an undefined slope. It's not even a function. Okay? And you can do that. These will not even have an x in them at all. Y equals 2 is an example of this. It's not a function. It doesn't even have x in it anywhere. Okay? So it has no slope. Well, it has an undefined slope. It's just a line straight up and down. Lines that are horizontal will say x equals to something. 5, let's say. There's no y value in that. Okay? And this just means x equals to 5. If we go to point y equals 0, what's x? 5. If we go to y equals 1, what's x? What's y? X equals 1, y equals 5. X equals 2, y equals 5. That's why that works that way. Okay. So different slopes, types of slopes. Questions on that? All right. Let's look at how we another way of actually writing these linear equations. We have a form of an equation, and I know you guys have all seen this before. It is called the slope-intercept, and in particular the y-intercept form of of a linear equation. Okay. The slope-intercept form, okay, we say that the slope is m, because we already mentioned that. The y-intercept we actually call b. You know what we call the x-intercept? A. Yeah, x-intercept A. The y-intercept is b. Remember what the y-intercept means. You've got a line, it's the point where it crosses the y-axis. Okay? That is point B. In fact, it's, if you want to do it in actual point notation, 0, b. That point right there is the y-intercept. Okay? If we write out our equation, the equation actually looks like this: y equals, and this is what Mark said earlier, mx plus b. Okay? That is called the slope-intercept form of linear equations. Y equals mx plus b, and we're going to use that a lot. We can also, of course, write it like this: f of x equals mx plus b. That's the same thing, but remember, we're just replacing y with f of x, and we can go back and forth and do that. Okay? So here's the example. Y equals 2/3 of x plus 5. Watch how easy it is to graph these. I'll put the link back up here. If you have something in this form, watch how easy it is to graph. Y equals 2/3 x plus 5. Oh, there it goes. Got it. Y equals 2/3 x plus 5. Okay. Where does it cross the y-axis? Isn't b? This is m is 2/3, and b is 5, which is where it crosses the y-axis. So our point, we know one point right there is 0, 5. Can I put that around there? Sure. 0, 5. It's right there. Now you use the slope that you know, and you just draw it in. Up 2 over 3. Rise over run. Up 2 goes 6, 7, 7 over 3. 1, 2, 3. Up 2 over 3. 1, 2, 3. Draw a line. You're done. Right? See how easy that is? If you have it in this form, you should probably narrow the movement and like not the end of the world. If you have it in this form, then that's what. Here we go. If you have it in this form, it's so easy to graph. You know the slope and you know the y-intercept. Put the y-intercept on the graph. Start you doing the slope a couple times. Draw a line. You only need to do it once actually, so you have 2 points. Very, very easy to graph that way. Okay. And you will see this form of the equation, y equals mx plus b, all the time. All the time. Okay.
Will m always be a fraction?
Nope. But well, m will always be a fraction because if it's a number, it can always be a fraction, right? Except for like irrational numbers, but you can always put it over 1. Like if this was y equals pi x plus 3. Yeah, you would probably want to just round it in this case. You'd want to say the slope is actually 3.14 divided by 1. And then you go up 3.14 over 1, up 3.14 over 1. Okay, and the y-intercept in this case is 3. Okay, but you can always turn it into a fraction. Good. Questions on that one? All right, let's try one on our own. Find the slope and intercept and graph 3x plus 5y equals 10. 3x plus 5y equals 10. Be careful though. Is it in the right form right now? We have to try to figure it out how to turn it into y equals mx plus b. I like subtract 3x. Subtract 3x. So you're going to get 5y plus 10 equals n minus 3x. Divide both sides by 5. And you have to divide each term by 5. Don't forget to do that. 5, 5, well, 5. Divide every term by 5. Y equals 2 minus 3x over 5. Is it in the right form?
Yes.
Kind of. Not quite. Is it y equals mx plus b? No. You're close though. How about just swapping those two terms? Y equals negative 3/5 x plus 2. Right? And then if you got it in this form, what's the slope? Negative 3/5. What's the y-intercept? 2. Erase this and do that on here. So we go to 0, 2. There's one of our points. Down. And then we go down 3 to the right 5. 1, 2, 3. 1, 2, 3, 4, 5. Boom. That's the only one I need to draw. And I cannot draw the line. I didn't get quite through the line, but pretend that I can draw a line through 2 points. Right? So in this case, is this a negative slope or a positive slope? It's negative, and it tells you it's negative when you look at the number itself. Or you could say, hey, it goes this way, which is a negative slope, versus this way, positive slope. Good. Right. Let's try another one. Let's try. Everybody done writing this one down? No, not yet. I'll erase the line. Let's try y equals 3. Right here. We don't need to do anything. Y equals 3. If you want, is this in the correct form? Well, it's not in the correct form only because it's not really a linear equation. There's no x term. But yeah, it's in the right form. We can say that the slope is undefined because it doesn't even exist here. And what's the y-intercept? Yeah, you can say 3 if you want. But really, y equals 3. Anywhere you go, x-wise, the y value is always going to be 3. Right? Y equals 3. So, 1, 2, 3. Sorry, you know what? I lied. It's not undefined. It's 0. Yeah. Don't catch me on these. That one's 0. Why is it 0? Because this really is, we could rewrite this. I'll rewrite it here. Y equals 0x plus 3. That's the way we could have written it. Right? Yeah. So y equals 0x plus 3 is the way we could have written it. So the slope is 0, and the y-intercept is, well, 3, but because any point on there, y equals 3. Okay, let's try x equals 2. Now we've got the undefined. So before, when I said it wrong, now we don't have a y value at all. So now we can say that the slope is undefined, and we can say there is no y-intercept in this case, right? And in fact, if you go over, you go 1, 2. There's your line. That's the straightest line I've ever drawn without a ruler. X equals 2. Okay, so you got to be able to draw these. Yeah. In your book, you don't have to look at it now. I got it here somewhere. Sure, there it is. In your book, on page. It's on page 391. On page 391, there is a graph, okay? And the graph looks like this, okay? The part that's important that we're going to talk about looks like this, okay? Let's see. This one. Okay. has, instead of numbers like this here, it has $2,000, $3,000, all the way up to $14,000 on the y-axis. Okay? On the x-axis, it says 99 as in 1999, 0001, 02 as in 2000, 2001, 2002. Okay? All the way over to 2009. Over like that. Okay? Sorry? This is on page 390. Well, the picture's on 390. The question is on 391. Okay? And what this says, the graph is labeled, it says average premium for employee-sponsored health insurance. Average premium. In other words, how much you have to pay for health insurance. Okay? This is going to show how much you have to pay. For the military, what would the dotted line look like? What do we have to pay for health insurance every year? We pay anything? No, it'd be this line. Right? Which is nice. We're in the military, and the military does all our health insurance for us. We pay them by allowing them to put us in position where we get shot at sometimes. Right? We pay that. Well, we pay our taxes pay, although not out here sometimes. But yeah, we pay in the end. We're paying, but you're getting more. Hopefully, you're getting more than you pay out in taxes, right? In your paycheck. Sometimes I'm feeling. But here's what it does. It has two lines on here. It says at 0 and 5,791, which on this graph would be about here. 0, 5,791. There's 1 point. And there's another point at, and by the way, it would really be at, I guess it would be, let's see, 99 is actually here on this graph. So 99 is here. So I'm going to relabel these. Forget about the numbers here. I'm going to label this 0, 1, 2, 3, 4, because that makes it a little easier. Then you can always add 1999 to it. That makes it easier on this graph anyway. Okay, so 0, 5, 7, 9, 1, and then 9, 12,680. 9, 12,000, which is like up here somewhere. 9, 12,680 is on there. And then they drew a line straight through it. From here, like that. Goes up into nowhere land. Okay. And it asks, it says, find the insurance premium for 2012. Okay? And 2012 happens to be how many years after 1999? So 2012 minus 1999 is 13 years. So at 13 is what we're trying to find the premium at. Okay? How are we going to go about doing this? Can we figure out a formula for that line? Slope? Let's figure out what the slope is. The slope is the rise over the run, or y2 minus y1 over x2 minus x1. In this case, it's what? How much up do we go? From 5,791 to 12,680. How do we figure that out? How do you know? You're just guessing. You're not just guessing. How do we do it? What's that? Okay, plug in the number. You plug in the y2 minus y1 for me. Okay.
5791 minus 12,680.
12,680. Okay, so you said that this was y2 and this was y1. Can we do that? Sure we can. Why not? Okay. What's the over amount? Careful. This is x2, or this is x1, and this is x2. Yeah, so actually you're right in that case. So it's going to be, yeah, it's going to be 0 minus 9. Because you're taking this one, this was just negative 9. So the rise is this number, over the run is this number. do this out. Do 5791 minus 12680 on your calculators. Forgot to hand out who wants one. There's one, here's one, and anybody else want one? Calculators? I'll have them up here if you need them. Okay? 5791 minus 12680 equals what?
-6, 8, 8, 9.
889. 0 minus 9 is negative 9. Do negative 6889 divided by negative 9. 765.4. Okay, we'll leave it at that. 4444. We'll just round it to that number. 765.4 is our slope. What's our y-intercept? You can read it right off the graph. Where does it hit the y-axis? 5791. Because isn't it 0, 5791? There's your y-intercept. Can we now? Do we have? We've got a slope, and we have a y-intercept. Can we write it in our form? Sure we can. Y equals what? There you go. 765.4 times x plus 5791. Okay, now we have a little formula. How many years did we say we're going to look for? 13. Isn't that just the x value in here? Because that's how many years over we are. Y equals 765.4. I'm going to turn this off so you can see it. 7654 times 13 plus 5791 gives you what? 18, what is it?
741. 1541.
741. 15741. 15741. I'm not going to worry about the point 2. Your bank probably won't worry about it. Well, they the price thing in there. $15,741 in 2013 is what you're going to pay. Okay? Which is a lot of money. And that's how we end up figuring out. Okay, what do we do? Oh yeah, we did that. That's right. That's actually on the. I think on the chart. That one was how much your employee has to pay. Oh no, that's for family insurance. Another nice thing about being in the military, you don't have to pay for family insurance either. You can have 17 kids, and the military pays for all of them. Actually, that's kind of true in regular business too. You pay a family for however many kids you have. Lucky you. Anybody have 17 kids? All right. That was the first part. I tell you what, let's take our break now. And because I was late too, and we'll go come back at 1:15. Okay, let's get going again. The next thing we're going to do, we're going to talk about how to solve systems of linear equations. Okay, and systems of linear equations are where you have two equations. They both have x's and y's in them. They're both linear equations. And you're trying to find out an x and a y value that makes both of those true. Okay? This is a system. This is a system of linear equations. System of linear equations. We can find a solution to this, which is just a pair of x and y values that make it works out. Okay? This one happens to be 3, 2. This is the solution to this. Okay? 3 minus 2, does that equal 1? Indeed it does. 2 times 3 plus 2 equals 8. 2 times 3 is 6 plus 2 equals 8. Good, 8 equals 8. So this point happens to be the one that solves that equation.
Where did you get that point from?
I picked it off my piece of paper, but I'm going to show you how we're going to do that. Okay? It's a very good question. Okay? And very apt. And hopefully by the end of tonight, you'll know how to do it yourself. All right? Okay? Let's look at how we might do this. Okay? And we can actually put this, we'll put it right here. We'll say, look, we're looking for 3, 2. Okay? Let me show you first, okay? Well, let's do this. Let's get these in slope intercept form. Always put them in that form if you can. This one, okay? 2x plus y equals 8. Let's subtract 2x from both sides, okay? And we'll get y equals negative 2x plus 8. I've already done a little bit of the switching around for you there. Okay? And the other one, let's see. If we add y to both sides and then subtract 1 from both sides, we'll get y equals x minus 1. Okay? Now, there's a whole bunch of different ways to solve these. Okay? Let me show you one way to solve them. Let's just graph them. Okay? Let's just graph them. If we were to graph these, let's figure this one out first. What's the slope of this? Slope equals negative 2 over 1. And what's the y-intercept? 8. Okay. So let's go to y equals 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 0, 8 is going to be our y-intercept. And let's go down 2 over 1, down 2 over 1. 1, 2 over 1. 1, 2 over 1, etc. I'm going to fudge this a little bit. Okay? All right, so we've graphed line number 1. Let's graph this one. What's the slope of this one? 1 over 1. That's an easy one. And what's the y-intercept? Negative 1. So we go to negative 1. Sorry, we go to negative 1 on the y-axis. I put a point there. And it's easy. We go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Oops. I can't draw straight anymore. Okay, and then if you were to do this on graph paper, you would find out that this point is 1, 2, 3, 1, 2, 3, 2. Is that what we're looking for? Yes. It is. The solution to these equations is where the graphs intersect each other. Okay, so that's one way to do it. Probably not the best way to do it because it involves lots of graphing, and you saw that I didn't, you'd have to do it on graph paper. And what if it ends up somewhere between 2 lines? Then you're like, well, you have to guess, whatever. But it is a way to do it. We can also do this a totally different way. Okay? I'll leave that right there for now. We can do this where we solve by substitution. Okay? Let's solve this one by substitution. In other words, solve for one of these variables and then take the answer of that and put it in place of that variable in the other equation. Let's try this one. This one seems a little easier to solve. If I want to solve for x, what do I have to do? It's really easy. Add y to both sides. So we'll get x equals 1 plus y. If it's x equals 1 plus y, doesn't that mean anywhere I see an x, I can put 1 plus y? Because we just said they're equal to each other. Up here, anytime I see an x, I'll put 1 plus y. So I'll do 2 times 1 plus y in parentheses plus y equals 8. Then I just solve for y. Now in this case, we got to distribute the y through. 2 times 1 plus 2 times y plus y equals 8. Okay? So this ends up being 2 plus 2y equals 8. Subtract 2 from both sides. Okay? You get 2y equals 6. Divide both sides by 2.
Why not 3y? You got 2y plus y.
Thank you. I got it wrong. 3y. How's that sound? And then that's going to be divided by 3. Thank you very much. Okay? And then we got divided by 3, right? Oops, that becomes 2, so this is y equals 2. We solved for one of them. Now in either one of those, you got to put y equal to 2 in, and that'll give you x, won't it? Let's do the easy one. We've already solved for x. X equals 1 plus y. X equals 1 plus 2 equals 3. So we've got x equal to 3 and y equal to 2. Isn't that what we're trying to find?
Yes.
It is. That's called solving by substitution.
And that is the easiest way.
Sometimes it's the easiest way. I'll show you another way, which sometimes is an easier way. Okay? All right. So, there's another way. We're going to practice these, by the way. Okay, we're going to practice these. Let me erase the graph at this point. Okay. All right. We can also do what's called the elimination method. Okay. The elimination method says if I have two equations and I can somehow like add those two equations together and get rid of one value.
Yeah.
For instance, what if I just added all of those terms together? Straight up. What's 2x plus x? 3x. What's y minus y? No y's. What's 8 minus,
Plus
what's that?
Plus 7.
8 plus, sorry, 8 plus 1 is 9. Now I've got 3x equal to 9. Divide both sides by 3. What do you get? X equal to 3. So far, so good. Then you take that and plug it back in somewhere. 3 minus 1, x minus y. X minus y equals 1. 3 minus y equals 1. Do this one in your head, right? Add both y both sides, subtract 1, 2 equals y. We've got x equal to 3, y equal to 2. There we go. If you can make this into some form where you can add it together or subtract it, it doesn't actually matter.
Which method is this?
You can do it. This is called the elimination method. Okay? This is the elimination method. This sometimes is much easier, or not much easier, sometimes easier, sometimes harder, but you can always do it. We could have eliminated it another way. Let's try doing it a slightly different way. How do I get what?
When you had 3 minus y equals 1,
When I had 3 minus y equals 1, yeah.
so the answer was 2.
Yeah, 3 minus what equals 1? 3 minus 2 equals 1? I mean, you can do the algebra, don't worry.
But you had minus 3 and then we negative 2. Oh, then the y, okay, I got it.
Yeah, y goes the other side. Yeah, minus y. Yeah. I was taking a shortcut. You probably shouldn't do it all the time. Okay, there's another way to do this. This one would probably be not the easiest way, but let's say that we multiplied everything in this. Let's say we want to get rid of the 2x. How do we get rid of the 2x by adding something to it? 2x plus what equals 0? Negative 2x, right? What do I have to multiply by this to get negative 2x? Negative 2. So if I multiply each one of these by negative 2, can I do that in an equation? Multiply each term by some fixed value? Sure I can. That's going to be negative 2x minus 2y equals 2. So far so good? 2x plus y equals 8. 2x plus y equals 8 plus this. What's 2x plus negative 2x? 0 x's. Y minus 2y? Negative
y. Negative y.
Negative y equals 8. No, it's not right.
Negative 2.
I did have it right. Thank you.
Negative 2.
Y plus negative y.
Plus 2. That should be negative 2.
Oh, no, you're right. How about that? That's what I should have done. I multiplied everything. Let me do it again. No, I'm making it hard and crazy. Let me do it again. If I multiply everything by negative 2, that was what we did wrong. Negative 2x
Plus.
negative 2 times y, negative y is plus 2y, thank you. And negative 2 times 1 is negative. Sorry. Martin, don't hate me.
They was the method right before that.
Go back to the file. Sorry, what did you say?
I'm gonna stick with the elimination method.
This is the elimination method. This is just a slightly different way of doing the elimination.
Oh, okay.
But you're gonna have to learn how to do this. You're gonna have to learn how to do this one too, because I'm gonna give you ones where you can't do it equally. We'll do that. We'll do other examples. Don't worry. Now, if I do, let's see if this works out. 2x minus 2x is 0x is y plus 2y is 3y. 8 plus negative 2 is negative 6. 6, positive 6. I'm thinking, I think. Divide each side by 3, and you get y equal to 2. Is that correct? It is. Plug y equal to 2 back in here. X minus 2 equals 1. X equals 3. 3 and 2. Okay. So there we just did this like 4 different ways. Okay. We will do an example where you have to do this, like the next one.
What is the
I'm going to
name?
make you do this one. All right. I'm going to redo this one like this. This is still the elimination method. Sorry, I didn't give you guys time to write that down
Way
yet.
to do that.
I'll just yell at me next time. Or you can go to YouTube. By the way, the answers to the final exam prep are on the website. I don't think I emailed you that, but Christine obviously found them. It's on the website. So if you just check the website, they're there. Okay, let's try this one. 2x equals 7y minus 17, and 5y equals 17 minus 3x.
I'm lost.
How are you lost? We haven't done anything yet. Well, just watch. Watch what we're going to do here. First thing we're going to do, okay? Let's get these in the same form. Normally, I would say y equals mx plus b form, but let's just make the terms at least line up. That's the first thing to do. Okay? Add 3x to this. Let's do this one. Leave the top one and make the terms line up. We're going to need an x over here, and the y here, and the constant there. Okay. So if we're going to do it that way, we're going to add 3x to both sides, and we're going to get 5y plus 3x equals 17. And then we're going to do what we're going to do. Minus 5y, 3x equals negative 5y plus 17. Is that the same form as up here? Okay, I haven't done anything. I've just done a little bit of algebra moving it around. So now, let me write it again right here. 2x equals 7y minus 17. And 3x equals negative 5y plus 17. Once you have it lined up like this, you got to pick a variable to get rid of. Let's see if we can get rid of the 3x and the 2x somehow. Okay? This is another one where you sometimes have to do a little like guessing and checking, but this isn't that hard to do in this case. What things can we multiply together to get these so that they'll be the same number? A 3 up here and a what? 2 down here, but let's make one of them negative so that when we add them, we'll get like 6x minus 6x when we add them together. So let's multiply this one by 3. I can just do it like this, and this one by negative 2. Okay? Let me go right back up here. I'll go up again. Actually, I'll keep going down here. This one. Multiply through every term. 3 times 2x is 6x. Equals 3 times 7 is 21y. 3 times negative 17 is 51.
Yeah.
Negative 51, thank you. Negative 2 times negative 3x, negative 6x. Negative 2 times negative 5y, 10y. Negative 2 times positive 17, negative 51, right? I'm sorry? Oh, 2, because I was thinking 3 again. Negative 34. If we add these two together, is the x is going to go away? Yeah. Let's do that. I'll do that up here now. 6 plus negative 6 is 0. 0 equals 21 plus 10, 31y. Negative 51 plus negative 34, negative 85. Okay. Let's add 85 to both sides. 31y equals 85. Divide by 31. So we get y equals 85 31s. Okay? $85.31. Once we have that, we can just plug back into anywhere we see y in either one of these, and then crank it out. Okay? It's kind of like 2 pages worth of stuff to do that, but I'm not going to make you go through all that right now. We've got other stuff we want to do, but the point is you put y, put 85.31s in here. I'll write it out at least. 5 times 85.31 equals 17 minus 3x. And then you crank through the math there, you'll end up with x when you do the algebra. I won't make you do a hard one like that on a test. Questions on that one? Okay, it ends up coming out as 34/31. X equals 34/31. And how do you check it? Plug 34/31 into this, and 85/31 into here, and see if that number equals that number. Check it. All right. Not so bad, hopefully. All right. Well, I'm gonna wait until you guys write this down. What's that? Think you missed something? I'll do another one of these. Yeah, let's do another. Let's see. Find another good one to do. All right, I'll make one up. Let's do y equals 6x plus 4 and negative 2x equals 3y minus 2. Okay, let's try that. Can I erase this yet? No? I'll start it without saying anything.
That's the elimination method, right?
Elimination method. Whichever method you want. I would probably do this one by substitution method. Because I've already got y. And I can just plug that right in there. We'll do it both ways. Now first we'll do the elimination method because that's what we already started. Then we'll do that plug in. I'm actually going to keep the 3y there. You'll see. I guess it doesn't matter. I guess I can do it. I'll do it that way. I'll do it that way. 3y equals 2x minus 2. That? Okay. So I'll rewrite it down here. 1 equals 6x equals 4. You get to pick which ones you want to get rid of, which variable you want to get rid of. I'm going to pick the y. I'm going to multiply everything by 3 on the top of it. That'll give me this down here. 3y equals 18x plus 200. Then I'm going to add 0 equals 20x plus 10. Subtract 10 from both sides. check it by saying, or I'm going to find a y by plugging in x equals negative 1/2 for this one, let's say. Y equals 6 times negative 1/2 plus 4. Y equals negative 3 plus 4. Y equals 1. Now, if I did it right, I should be able to check it, right? This one's actually a pretty easy one to check. Y equals 6x plus 4. Y equals 6x plus 4. 1 equals 6 times negative 1/2 plus 4. 1 equals negative 3 plus 4. 1 equals 1. Works for the top one. I'll also check for the bottom one here, this one. Negative 2 times negative 1/2 equals 3 times 1 minus 2. 2 times negative 1/2, negative 2 times 1 is 1, equals 3 minus 2. 1 equals 1. Check.
Why would we do 6?
What happened to which?
Do 6 over here.
Which 6?
You divide it by 2?
Here?
Yeah.
What's 6 times negative 1/2? 6 times negative 1 over 2. 6 over 1 times negative 1 over 2 is 6. Negative 6 divided by 2 equals negative 3. So that became negative 3. All right. We did that with substitution. We did that with elimination. Let's do it with substitution. Why not? Same one. We'll do it with substitution. We're still writing these ones down. All right. Substitution. As I said, I would probably do this one straight off the bat with substitution because, by the way, does anybody know why I always try to erase side to side and not up and down? I'm sorry, erase up and down, not side to side. I always try to erase up and down. You don't know why?
Does the title?
No, when you erase side to side, your butt jiggles.
Oh.
Okay.
That's
Yeah.
good one, sir.
Thank you.
This-
Okay.
I need that.
All right. If you've already got y, take what that value is and plug it in right there where you see a y in the other one. Negative 2x equals 3 times 6x plus 4 minus 2. Negative 2x equals distribute 18x plus 12 minus 2. Negative 2x equals 18x plus 10. I don't know, subtract 18 from both sides. Sorry, subtract 18x from both sides. You get negative 20x equals 10. Divide both sides by negative 20. And you get x equals negative 1/2. So that's pretty easy way to do it. Then you can plug that back into either one of those. I'll lay it right down there.
So this is just another way to do substitution.
That is a substitution method. The one we did before was the elimination, where we eliminated one formula. Now we're saying substitute one value into the other. And again, if you wanted to graph these things, they look something like this. Y equals 6x plus 4, y-intercept is 4, up 6 over 1, should be like that, right? And then this one, well, let's see, this is going to be y equals negative 2x minus 2 divided by 3 divided by 3. So, yeah, that's right. 3y, all I'm doing is y divide, no, it's going to be, you're right, positive 2/3, right? Yeah. So it's going to be positive 2/3 is the intercept, which is like there, and then it's going to be negative 2/3, so down 2 over 3, down 2 over 3, like that, right? And that's where they crossed, right there, which was, up there we got negative 1/2, and what did you say the other one was? 1. So that's drafted. Question. These ones had crossed at exactly one point. Right? The ones that we've shown so far have all crossed at one point. How else could you have lines? Okay, so let me just erase. Everybody done writing this one down? Okay. How else could you have it? We could have cross at one point, parallel lines, which would be like a line that goes like that, and another one goes like that, and they're like railroad tracks, they never cross. Okay. If this would be arrows, so forever. If they're actually parallel, are there any solutions to this where they cross? No. This is the kind of thing where you end up getting like 6 equal to 5 when you do all this substitution and stuff, and you go, no, that doesn't work. Okay? What's another way? There's a third way these two lines could cross each other or intersect with each other. What do you think? I'll give you a hint. I'm going to use 2 different colors for this one. That was one line. Couldn't I also have that being the other line? Is there still 2 lines? One's right on top of each other? Sure. Okay, so there's 3 different ways for things to cross. They can either cross at one point, they can cross never, or they can cross always. Okay? And this is when you end up getting like x equals to x or something like that. We go, oh, wait a minute. Now it is true, and they're equal to each other. We'll do some examples of both of those. Can 2 lines with the same type of slope, positive, cross each other?
Same slope.
Not the same slope. Well, that would be this one the only way. What if they have a slightly different slope, but they're both positive?
Probably eventually.
Can I cross some other positive slope with that one? Sure, I can just make it like that, right? This one happened to be a positive slope and a negative slope crossing, but you can also have it cross the same positive or negative, just to point that out. Okay? All right. So let's do an equation. Let's do the following one: 2x plus 14y equals 18. 2x plus 14y equals 18. 2x plus 14y equals 18. And we're also going to do 3x plus 21y equals 27. I put this on the guide. Just means that's the set of equations. There's an elimination we can do for this one. Okay. Let's do. They're both divided by 9? I'd say it's a good idea, but let's do this. Let's do 3 times the first one, 3 times the first one, and negative 2 times the second one. Okay? Same thing we did kind of earlier, right? This is going to be 6x plus, what's 3 times 14? 2, 1. 3 times 14 is 42. This one?
Yeah.
Doesn't matter. Do either one. If I do 3 and negative 2, this will become 6x, and this will become negative 6x. And if I add them, we'll get rid of this term. I'm trying to do.
Yeah.
Right? 6x plus 42y equals 18 times 3. 1, 2, 3, 51. 54. Boy, I'm crazy tonight. Okay, 54. And then negative 2 times here is going to be negative 6x plus minus 42y equals 54.
Negative
Yeah, what
54.
the?
Negative 54.
Negative
So let's do
6x minus and plus negative 6x is 0. 42y minus 42y
0.
plus 0. And And 54 minus 54 is 0. And this is the one where you've got the lines on top of each other, because those are actually the same line. Actually identical lines. And by the way, if you tried to put this in y equals mx plus b form, you'd be doing all this algebra and you'd get the same exact answer for this line and for this line. You get the same one if you did the y equals mx plus b, because you're not dividing and subtracting the last one. Okay? So let's do that. Let's solve one of them for y. Let's do the first one. 2x plus 14y equals 18. 14y equals 18 minus 2x. So I'm just subtracting 2x from both sides. Okay. Divide by 14, y equals 18 fourteenths minus 2x. Okay. Over 14, thank you. Over 14. So then we can divide everything over here by, let's see, we can say that's y equals 2 goes into 18, 9, 2 goes into 14, 7, minus 2 goes into 2x, x, and 2 goes into 14, 7, like that. Y equals 9 sevenths minus x over 7. That'll work. Or y equals, let's do it in proper form, mx plus b, that will be negative 1/7 x plus 9 seconds. That's your answer. And this is how you write it out. Kind of looks a little silly, but you write it out like this. You say x comma y such that y equals 18. Well, I'll do that when we get over here. Correct. 1/7 x plus 9 seconds.
Negative 1/7.
Negative 1/7. X and y such that that's true. And that's our answer. There is no x and y answer. That's the whole answer.
So it's not zeros?
Well, it's not zeros because the answer is those two lines overlapping. So how many points are there? All the points on that line, which is that line. Okay, so if you drew this line out, right, you'd have some negative slope at 9/7. So it'd start here and be something like, let's see, down 1/7, so it'd be kind of like that. And that line, both of those lines, would end up on that same line. And that's the answer. All the points on that line is what this is saying. All the points on this line.
Are we going down?
Are we going the other way?
The bottom.
Thank you. Negative 1/7. I did do that wrong. Negative 1/7. Negative 1/7. Thank you. Like that. Good. Just keep me honest. Okay? Let's try another one. Let's try one that looks like. Solve 4x plus 6y equals 12 and 6x plus 9y equals 12. I'll give you a hint. Multiply the first equation times negative 3 halves. You can do it the other way where you multiply this one by 6, this one by 4. But if you do this by 3 halves, it'll make it easier. I probably won't give you one part like that. Unless, well, I mean I could, but you can do it lots of different ways. Let's just make it easier right now. Negative 3 times 4 is negative 12, divided by 2 is negative 6x. You see where this is going, by the way, already? Negative 3 times 6, negative 18 divided by 2,
Negative 9.
negative 9y. Negative 3 times 12 is negative 36 divided by 2 is negative 18. if you add these?
0
0 plus 0 equals
negative 6.
negative 6. 0 equals negative 6.
Not gonna happen.
It's not in this universe. Right? So that is not true, which means there's no solution. Those two lines are actually what to each other? Parallel to each other. If you were to graph them, you find that one line would be, let's see, I'll get this, try to get this right. 6 lines of negative. So one line would be like this, and the other line would be like that, and they'd never cross each other. So the solution is, right? X. It's like that. No solution. Still right. Stuff just takes practice. And you know, again, builds on the last stuff we did. So if you can get the algebra part down, then it's a matter of learning later this stuff. Okay? So people ready. The next problem we're going to do is a word problem. Okay, look, you're going to see lots of word problems on your final, I guarantee it, so you better get used to them now. Lots of word problems. Okay. Here's the word problem. A company manufactures wheelchairs. Why wheelchairs? I don't know. They're manufacturing something. Okay? They're manufacturing wheelchairs. Company manufactures wheelchairs. Okay? The cost for the plant and for everything that goes into the initial cost for the wheelchair company is $500,000. I'm going to abbreviate that, 500K. Okay? And I shouldn't abbreviate it. I'll just make it $500,000 to start the plant, to build the plant. Okay? And it's got an extra cost, okay, of $400 per chair. $400 per chair. Which in this case is going to be 400 times X being the number of chairs. Okay? You can sell a chair though for $600. $600 for each chair sold. Can we find out, well, first of all, what's our formula for the cost to produce X wheelchairs? X wheelchairs cost blank. Dollar sign. Can we figure out what that formula is? Try it. Almost 400X. Getting there. That would be great. I would make wheelchairs tomorrow if I could have no startup cost. Right? There you go. So it's going to be 500,000 plus 400X. We'll call this C of X being the chair cost for some number of chairs. What is our revenue cost? In other words, our cost, or sorry, it's not our revenue, it's our revenue function, which is how much money we get per chair. Yeah, our revenue function is just 600X. What is my break-even point? In other words, how many chairs do I need to sell so that I don't lose any money or make any money? You could graph it and find out, or we could just do some algebra so we don't have to worry about the graph paper. Remember how I said just replace these functions with y's? We're going to graph this. We would graph y equals 500,000 plus 400, and y equals 600. And by the way, if you're trying to graph this, that's going to be a really big number, so you have to have your scales kind of weird. It wouldn't be the most fun thing in the world to graph. Okay? But let's figure it out. So we've got y equals 500,000 plus 400x, and we've got y equals 600x. Actually, I'll just do it this way, because I'm not going to use the elimination method. I'm going to use the substitution method. Where am I going to substitute this up here? For y. Because y equals that. That means wherever I see y, I can put that. So I'm going to put 600 equals 500,000 plus 400x.
600x.
600x, thank you. I'm going to write it bigger. 600x equals 500,000 plus 400x. How do I solve for x? Subtract 400x for both sides, let's say. Subtract 400x minus 400x. We get 200x equals 500,000. Divide by 200. 200, let's see, that, where's that? 5,000 divided by 20. 10,000 divided by, what is that going to be? It's going to be 2,500. X equals 2,500 shares. You have to sell in order to break even. All right. On the test tomorrow, one problem is going to be one of these. How do you solve it? Figure out a way to solve a problem. There is going to be an algebra solution. And if you want to do the algebra solution, good on you. I'd be 100% happy. 110% happy. You can also do it some other way, like do a table, or do a drawing, or do a guess and check, or whatever. Or at the end today, we'll go over that first problem, the one on the practice today. Do you remember? Do you remember last week when we brought up the number of chickens and the number of pigs? Damon's like, I've heard this 20 times. The number of chickens and the number of pigs and the number of feet involved. Remember how we had to do that, where you could draw the pigs, and you could count the feet, or you could guess how many pigs, and multiply by 4 feet and 2 feet and all that? We're going to do the algebra solution right now. Okay? Let's do it. Farmer Smith. Farmer McDonald, the elderly man, has Farmer Smith has chickens and pigs. Chickens and pigs. Okay?
No pigs.
There's what?
No pigs in the book.
There's no pigs in Djibouti? Probably true. You know, I saw a video last night on YouTube about people who feed hyenas in Ethiopia. They basically go out and they sit down with a bucket full of some sort of meat. And they just sit there. And then all of a sudden hyenas come walking up and they like throw the meat and they grab it. Hyenas are like giant, ugly dogs. Right? And they look really mean. And they could like break your neck with their mouth. But they're actually kind of nice, it turns out. But there's some pictures that I saw that are amazing. They're like just their eyes, and they can see the guy with the bucket. You see just all these eyes around. Then another picture, it's just like all these like giant dog-looking beasts. It's kind of scary. Anyway, Ethiopia, right? No picture, I guess. All right. Farmer Smith has 20 animals. 20 animals, and he has 64 feet, not including his own. Okay? 20 animals between the pigs and the chickens. 20 animals, 64 feet. C is the number of chickens. And P is the number of pigs. Okay. And we can write down some formulas here. If If we want to know the number of animals, what formula can we write? C plus P, because that's the chickens plus the pigs, equals what?
20.
Not 64?
20.
20, because he's got 20 animals. Some number of chickens plus some number of pigs gives you 20 number of animals. What else am I going to write? 64 feet. So I'll have to do it right here, 64 feet. What am I going to do to get 64 feet? Okay, how many feet does a chicken have? 2 feet for a chicken times number of chickens plus 4 feet for a pig times the number of pigs equals 64. Do I now have a system of 2 linear equations?
Yes.
We do. So let's see. What can we do to this to solve it?
Times 2 minus
What's that?
times
Times negative 2. I like that. We can do elimination. Multiply the top by negative 2. And then add to the bottom. Negative 2 times C is negative 2C. So far, so good. Negative 2 times P is negative 2P. Negative 2 times 20 is negative 40. I add these two together. I get 0 chickens, and I get 2 pigs equals 64 minus 40, 24. Divide both sides by 2. I get the number of pigs equals 12. C plus P equals 20. C plus 12 equals 20. C equals 12. 20 minus 12 is 8 chickens. 8 chickens. Now, isn't that easier than using the drawing out and guessing and checking and all that? Danny says not guess. He's like special. I think this is the way to do it. This is the way a computer would do it in some sense. A computer wouldn't guess and check. Okay. Questions on that? All right. So here's what I want to do. Let's take another break, and then when we come back at quarter after, we will go into doing some practice on this stuff. And then after that, let's say I'll leave half an hour at the end to go to the test for anybody else who wants to do it. Sound good? All right.